Hello, and thanks for clicking on this next Prenarculus production. Today, we're going to talk more about sum and difference formulas. We're going to do some advanced stuff with sum and difference formulas, establish identities, solve some equations, and do some algebra with them. All right, so let's get started, and we'll see how this all is going to play out here. So, the sum and difference formulas, here they are again. They were also on the last video. So feel free to write them down if you need to. We talked on the last video how you can easily remember them, hopefully, and all the stuff that they can do using angles on the unit circle or off the unit circle. All right, so let's start with something that's fairly complicated. I want to find the sine of the arctangent of 2x minus the arccosine of x. Okay. This is fairly complicated. Arctangent. Arctangent. Well, that's like inverse tan. That is inverse tan. That means I want you, this is the ratio. 2x is my ratio. Now, 2x is not on the unit circle. Okay? And I want to know the angle that it belongs to, but I don't know the angle that it belongs to, so I'm going to call it something. I'm going to call that angle U. I don't know what it is. Okay? And then over here, I want the arccosine of x. Again, arccosine, that's the inverse cosine of x. X is not a ratio on the unit circle. So I'm going to call this angle that I don't know V. So what I'm asking you to do is find for me the sine of U minus V. Well, that is a formula, right? Sine U cosine V minus cosine U sine V. We'll write it down. Okay. Now, what do we do with this U is equal to the arctan of 2x? So we'll come over here. So it means that in the angle U, the tangent has a ratio of 2x over 1, let's say. Well, if the ratio is 2x over 1, we can make a triangle for it. So that's what we're going to do. We're going to make our triangle in quadrant 1. We're going to assume x is positive. Tangent is y over x. So the y coordinate is 2x. The x coordinate is 1. Y over x. And now I need to find r. Well, I could do that with the Pythagorean theorem. Let me do it over here so I don't run out of room. So I got 1 squared plus 2x squared equals r squared. So 1 plus 2x squared is 4x squared equals r squared. Take the square root on both sides. Technically, I need to put plus or minus. So r is plus or minus the square root of 1 minus or 1 plus 4x squared, but r has to be positive. So we're going to say this is 1 plus 4x squared. Oh, let's try again. Let's try again. Oh, there goes the whole triangle. All right. So we'll go with the square root of 1 plus 4x squared. Okay, that's my first triangle. I'm going to do the same thing over here with V. V is the arccosine of x. So I'm going to go in quadrant 1 again. And I am going to make a triangle. Put 1 underneath. Cosine is x over r. So x is x. So all is right with the world there. R is 1. I need to find y. So I'll do it up here. So we have x squared plus y squared equals 1 squared. So remember, we're solving for y. X is actually a variable. So y squared equals 1 minus x squared. Take the square root on both sides. We get y equals plus or minus square root of 1 minus x squared. But y is going up, so that's 1 minus square root of x squared positive. Okay, now, here's my V triangle. Here's my U triangle. Remember, don't forget to label them. That way you know which is which. And I want to find the sine of U minus V. So sine U. Go to the U triangle. Sine is y over r. So that's going to be 2x over the square root of 1 plus 4x squared. Times cosine V. Cosine is x over r. So that's x over 1, you could say, if you want. Oops, should be minus in the middle. And we have minus cosine u. Cosine is x over r, so that's 1 over the square root of 4, 1 plus 4x squared. Sine v is y over r, that's the square root of 1 minus x squared over 1. So we're going to multiply straight across. We get 2x squared over the square root of 1 plus 4x squared minus square root of 1 minus x squared over the square root of 1 plus 4x squared. And now the denominator is common, and then we're going to subtract the tops, but we really can't subtract them. We just kind of have to leave it there. And this is my answer, 2x squared minus the square root of 1 minus x squared over the square root of 1 plus 4x squared. Okay, so like I said, definitely more complicated than what we did on the last video. All right, next. I want to establish this identity. So here we go. I want you to work on the left side and show me that the answer is cosine x to this problem. Sine of pi over 2 plus x is equal to cosine x. All right, so whenever you see something like this, the immediate thought that should go through your head, the bell should be going off, and it should be saying to you, hey, that's a sum identity that I know for sine. Well, that's what you should use then. So the sine of pi over 2 plus x is equal to sine pi over 2 cosine x plus cosine pi over 2 sine x. And I have to get cosine x as my answer. All right, now, this is like a combo problem. We got sine of pi over 2. That's on the unit circle. Sine's the y-coordinate. The y-coordinate there is 1. Cosine x, I'm just going to leave it there for now. That's what I'm trying to get for my answer. Cosine pi over 2, 0, 1, right, is the point at pi over 2. So cosine is the x-coordinate. That's 0. Times sine x equals cosine x. 0 times sine is 0. 1 times cosine is cosine. Hey, we did it. Cosine x is, in fact, cosine x. So whenever you see something that looks like, hey, this looks like a sum or difference identity, and you want to try to establish the identity, you should use it, okay? It's definitely a clue that you should use that identity and then see what happens, all right? All right, and finally, I want you to solve this equation on the interval between 0 and 2 pi. Cosine of x plus pi minus cosine x minus 1 equals 0. Okay, now I can't distribute cosine, but this is an identity, so I'm going to use it. So cosine of x plus pi is cosine x cosine pi plus sine x sine pi. So that's equal to all of that. So then I got to bring down minus cosine x minus 1 equals 0. So now I'm going to do some math here. Cosine x, that's negative 1. So that's negative cosine x plus sine pi, that's 0. So that's sine x times 0. All right, we'll take another step. Minus cosine x minus 1 equals 0. Sine x times 0, that's gone. Negative cosine x and negative cosine x is negative 2 cosine x. Oops, minus 1 equals 0. So now I'm going to try to solve for cosine. Add 1 on both sides. I have negative 2 cosine x equals 1. And divide both sides by negative 2. I get cosine x has to equal negative 1/2. Oh, now I'm back on the unit circle again. Cosine's x-coordinate. Where's the x-coordinate? Negative. X is negative in quadrants 3 and 4. Cosine is a half. The reference angle for a half would be pi over 3, but that's in quadrant 1. In quadrant 3, that's 4 pi over 3, and in quadrant 4, that's 5 pi over 3. So x must be 4 pi over 3 and 5 pi over 3. And that's my answer. Okay? And that's how we do some advanced things with these sum and difference formulas. So whenever you see the application of a sum and difference formula, or you see one, you should apply it, and it should help you to get into a scenario that should look a little more familiar. Okay? And as always, thanks for clicking.